Let's walk through the example. Just a few of you are still writing it. So let's walk it through. Why do I say sign chart? Because, isn't this what we did in the sign chart before? We figured out the zeros, we plugged it into a number line, we chose a number from each and every interval that split my number line into, and we plugged it in. Now, in this case, and I said it kind of in the video, some of you guys, I'm not going to walk through this entire thing necessarily right now, at least not showing you everything literally, that I did yesterday at the end of your video. By plugging in, I'm not necessarily plugging it into a function. I am, but we have to look at plugging it into the entire expression. But if you guys notice, did I plug it into the nasty, I have to square stuff and single stuff and this, that, and the other? I plugged it into the factored form. Why do you think I did that? Kind of just to make it easier so I could check the signs real fast. Because if I have 0 on this side, all I have to do is check the signs. And as soon as I see positive, I'm like true. And as soon as I see negative, I say false. Oh, there's a negative right there that got crossed out. You guys might not see that with the crossed out. I just noticed that. Can you see the -6? Mm-hmm. There you go. Okay. So any of the true portions, -3 was in what part of my number line? This part. And what is this part? Negative infinity to -3. Ooh, what was my mistake? -3 points me to a place in the number line, but the interval doesn't stop at -3. When does it stop? All right. Help me out. Let's change it. And then similarly, 4. He's a part of the interval, but what's the entire interval? What should be here? 3. The key numbers should stop those intervals, not the numbers that you tested. The key numbers should stop those intervals, not the numbers that you tested. Does anybody remember what this little U is for? Union. And union stands for what word with inequalities? Close. 4. And is the overlap, or is, hey, this piece and then this separate piece? So since there isn't an overlap, since I'm not talking about an overlap, technically my answer would be, hold on real quick. I mentioned it in the video, but a lot of you guys were writing today, which means you didn't watch that part. Why are there open circles above the -2 and 3, and why did I put parentheses? Oh, I still didn't change it. Silly me. Why did I put parentheses and not brackets? These are the zeros, and am I allowed to have a 0 or equal to? But what if it wasn't or equal to? What would I have done? Fill them in and made those brackets, because or equal to would be okay. All right, so let's go back to our steps. Find all the key numbers, the real zeros. Now, hold on. I need to add a little note. Make sure I didn't write it somewhere else first. Should I add to these steps somewhere? Oh, I do add to the steps. Let me still put it here. Since this is the first time you guys see it. Find all the key numbers. Get the inequality. Solve the inequality. Let's do solve the inequality for 0. Let's say solve the inequality for 0. You guys remember with quadratics, before we ever start factoring, what do you have to make sure that we have all set up right? The quadratic, before you ever start factoring, what do you have to have on one side? 0. You can't have a number over there. You have to move everything to one side and get a 0. I need you guys to think that with these inequalities as well. We want to get 0 on one side, okay? Just a quick heads up. Now, technically, if we were to go to this graph, kiddos, we're looking at this as a number line, right? And we're saying, hey, this number line, sweet, everything this way, everything that way. But the problem is this a line? No. Who is this? What is this? A quadratic, and since it's a quadratic, what's its graph look like? A parabola. So,
Is the graph going to look like this?
No, and that's why you might have seen it a second ago. That's why I give you this quick sketch. Here we go. Of what's really going on. Now hold on, wait, what's weird? I have the open. Uh-oh. Why are mine backwards? This one shows the inside, right? What's going on? Yeah, did you notice it? Yeah, I didn't notice it until today. Yesterday I was going super fast before calculus BC came in. What was my mistake? Do you see it? Did anybody else notice he randomly flipped? Yeah. Karina noticed. He only randomly flips when you multiply or divide by a negative. Did I multiply or divide by a negative? No. It's called yesterday. I just literally forgot what I was supposed to be doing. So what's the struggle? All the ones that were true are now what? False. All right, so let's fix them. It'll just take a second. Okay, that further cements the idea, right? Because we have to make sure we have everything perfect, or else we're going to get the wrong solution. Those positive 6s were actually the reason why, these outside intervals did not work. Hopefully for you guys, because you didn't write as much crazy stuff in your table, you can just change the t's to f's and then f's to t's. So we had our -3, we had our 0, and we had our 4. So actually what was true before is now false. What was false before is the only true. So those positives were actually a reason for it to not work, because we were looking for the negatives. That didn't work, that's false. And then this one, the -6, was the only one that did work. Hence why these are true. So then the open circles were still great. The open circles were still good. But those outer regions were actually the false ones. And what I need to do instead is the inner region, right? And the inner region, using the key numbers, using the zeros, it's going to be the shared part, which you can tell in the parabola is that part of the parabola in between these two zeros. And it would just be still open because at 0 doesn't work. It's not or equal to. Okay. You guys got them all fixed? It all makes sense? Watch out for the or equal to, whether or not to have these be open with parentheses or closed. Watch out for rewriting. That's sometimes the most dangerous step. But otherwise, you're asking yourselves the question, true or false. Okay. From that, sadly, we're going to have to face something that's even a little bit messier. I'm going to show you an example real fast if I can get there. What's different about this example? There's a top and a bottom. Stink-a-dink. Well, hold on, let's get back. If it actually gets back. Rational. So the first ones we looked at were polynomial inequalities. And more specifically, I think you'll probably mostly see quadratic. It could go cubic because you are supposed to be able to factor those, but you could have polynomial inequalities. You're supposed to get everything to one side with a 0. Factor, find the key numbers, put them in a sign chart, and test the signs. True or false? Are the statements true or false? Rational, the other type of function from this chapter. F of x over g of x. You have a top and a bottom. Or if you have a rational function that's in an inequality, the clue for him. A rational function can only change signs at its zeros or its undefined points. You don't necessarily need to put this in your notes, but why the undefined points? What if I was to have something like let's do 1 minus 1 over x. Do I want that? No. Let's do 1 over x minus 1. Okay. 1 over x minus 1 is actually going to have a horizontal asymptote at -1. Bottom wins. 0 minus 1, -1. The whole thing gets shifted down 1. And I'm going to have the parent function that I've seen before. Okay. One place that the function changes sign is at the 0, right? And what do I mean by changes sign? The y values change from being positive y values to being what? Negative y values. From being above the x-axis to below the x-axis. But question, where else is this function changing from above to below? Across the asymptote. Now, not literally that the function is going across the asymptote, but the 0, it can change from above to below or below to above. And at an asymptote, it can change from being above to being below. Do you kind of see? That's the idea. That's why we have to check for the key numbers, not only the zeros, but also the undefined points. So for our key numbers, we're going to use all the real zeros and or the undefined points, whatever it has. If it has zeros, we're going to steal those. If it has undefined points, we're going to steal those, and we're going to put those into our sign chart. Shortcut for finding the key numbers. Now, this only works if the inequality is solved for 0. Okay? The shortcut only works if the inequality is solved for 0. If the inequality is not solved for 0, we're going to be in a little bit of trouble. But if the inequality is solved for 0, the quick shortcut is you have an f of x over a g of x. I want you to think of pitchfork, the sideways pitchfork. The zeros come from setting f of x equal to 0, and the undefined points come from setting g of x equal to 0. Okay? Whenever you have a fraction, as long as the inequality has 0 on one side, sometimes it'll have a number, and we'll see that in the next example, but if it has a 0 on one side, to find the zeros, just set the top part equal to 0. To find the undefined points at the bottom equal to 0. Remember, domain, we only look at the bottom, but we can look for x-intercepts up top, just not vertical asymptotes. So undefined, look at the bottom. Zeros, look at the top, but only if you have it solved for 0. So, the door's open. Hopefully we get some air in here. I know it's warm. Let's go check out our next example. But actually, do I have an easier example? Nope, we're going to do the hard one. Before we get to the hard one, let's quickly look at steps. It's up to you as to whether or not you want to write them. It's up to you as to whether or not you want to write them. 1. Look at the other steps. Can we look at the other steps real quick? For the polynomial ones. What was the first thing? Find the key numbers. What's the one difference in this entire page? What are the key numbers for rational functions? That's the only difference. But otherwise, you find the key numbers, you put them in the sign chart, you pick test values from every single interval, you plug in and ask yourself the question, true or false, and then you compare to the original and say, hey, the true one's good, the false one's not good. Check the or equal to see whether or not to bracket it, whether or not to fill it in. So, if you want, you can go back to the old one and say, key numbers for polynomials, if you want, instead of writing this whole thing over again. You can say, key numbers for polynomials, they're just the zeros, right? Key numbers for rational functions, they're zeros and undefined. So they're technically the exact same steps. I just need to make sure that you guys put down somewhere. Key numbers for the polynomials, just the zeros, because it doesn't a denominator, and key numbers for the rationals include the denominator as well. Include the denominator as well. Okay. So with that, let's go ahead and go face and tackle another example. If you want to leave space to write this over again, feel free. Just you're going to have to skip it. Skip the lines and then come back to it. But remember, it's the exact same steps to solving, just the key numbers are different. Okay.
What do you mean by undefined numbers?
When the denominator equals 0. And you plug that in calculator over 0 undefined, so it means it doesn't work. No. What's the dilemma with this inequality from the get-go? What don't we have on the other side? 0. Now, I'm going to do it a long way. And I'm going to show you why, if you do it a short way, you're going to forget something and it could be a problem. Okay? I'm going to do it a long way. You're going to be like, ugh, this is so annoying. Why don't we just multiply x minus 5 to the other side? That would be the easy way. But we're going to lose the discontinuity. So let me do it the long way, and I'll show you the easy way. We'll have to compare the two and say, okay, what does it work either way? Ready? What time do we get out? Who knows? It started at 15. 55? I have it somewhere. Thank you, the assembly schedule. Technically, I'd say the safest way is to get a 0. What do you got?
We get out at 11:15. No, the schedule was different. It was weird today.
The assembly schedule.
Wait,
No, it's the assembly. Do we have assembly on there?
There's
No assembly schedule.
no, it's just
Or pep rally schedule. Pep rally schedule?
pep rally. No, pep rally schedule would do. It would be after.
Oh, it would be after. Never mind.
If we were on pep rally.
Okay, I'll find it. Kiddos, can you move the 3 to the other side? I'll find it. Mr. Richmond sent us an email somewhere.
First period was
3 gets out at 10:59. Okay. And then fourth period gets out at 48. And then fifth period gets out at 37, and lunch gets out at 107. That's not confusing. Okay, 59. That's all we need to know. Okay. I got myself a 0, right?
Yeah.
Oh. Now what? What about that 3? He's messing everybody up. He's just kind of random and out there. Question. How do we put these two together properly?
And then multiply.
3 is over 1, and over 1 doesn't cut it. But over x minus 5 would. Don't kill anybody. True? Then I have to go ahead and be like, no, I'm going to do some very dangerous math. Don't do this at home. But I have 2 fractions with a common denominator. Can I put it all over x minus 5? Real quick, this is not an equals.
It's an arrow.
I'm just saying, hey, let's take it over here. I can put it together. 1 fraction, right? That wasn't the dangerous math. Well, maybe it was, but it shouldn't have been. The dangerous math is 2x, let's distribute, minus 3x. Woo! Don't make any mistakes.
Wait.
Oh, okay.
2x
Minus
3x. True?
True. Yeah.
Yes.
Okay. And then negative 7, don't do this at home, just show the work. But negative 7 plus 15. Negative 3 times 5, positive 15. Negative 7 plus 15 plus 8. Woo! That was
Alive
close.
from the massacre.
We made it. Flushed it out of the jaws of death. Okay, so how do I find my key numbers? Since I have a 0 on that side, I can say, take that cheater shortcut and say negative x plus 8 over x minus 5. Let's set the top equal to 0 and the bottom equal to 0. When will the top be 0. Negative x plus 8 equals 0. When x equals
8.
subtract the 8, divide by a negative at 8. There's one key number. Set the bottom equal to 0 at x minus 5 equals 0 when x equals, woo! There we go, we got it. Okay? We had to work a little bit in the beginning, but we got both of our key numbers. Now, I should take a second. I'm going to show you, because a lot of you are like, why don't we just multiply in the beginning? All right, so what if we took, just real quick, I'm going to delete this page. What if we took our, I have no idea, what was there in the beginning?
0 minus 7 over x minus 5.
Oh, I wrote it wrong.
Less than or equal to.
Okay, some of you were like, just multiply. Okay, just multiply. 2x minus 7 less than or equal to 3 times x minus 5. 2x minus 7 less than or equal to 3x minus 15. I lost my voice somewhere in there. Negative x subtracting plus 7. Less than or equal to negative x plus 7. Negative 8. X is greater than or equal to 8.
And then the bottom just equal to 0.
That's the answer? So why on earth am I making it so complicated?
And
Check it out.
plus or equals to 0. And we got
The undefined number could separate stuff. So hold on, let's go back. Entire page. Let's do it my way, and let's see if it's the same answer. Okay, ready? Now what? What am I doing? I'm splitting up my number line to say, ooh, I need to test each of those. Yeah? Testing each of those. Oh, I'm testing them by plugging in who? I don't know, things in between. Like, what's something to the left of, I don't need it that big, do I? Yeah, something to the left of 5 is 4. Or 0, that sounds easier. Something, sorry, I trumped it. Something, Steve, that doesn't work in here.
I was confused.
Oh, that's lame. Anyway, I have to think of another way of saying it. Between 5 and 8, 6. Between 8 and whatever, 10. Sean.
In the fork, why is x equals 5 not x? Not equal to 5 because of the denominator problem.
Technically, the domain x cannot equal 5. I was saying the bottom equals 0 at 5. So my statement was technically okay, but in context of the whole thing, you're right, it is an undefined point. Just to remind us. But the undefined not equals is at 5. Let's see if we can put that together. Kiddos, can we just be amazing real quick?
Yeah.
Just for sake of time? Because we get out 59. Don't do this at home. I'm going to take the 0, and where am I going to put him? And I'm going to ask true or false. And we're going to see if we can do it all at once. Careful. Plugging in 0. Negative 0 plus 8. Over 0 minus 5. Negative. A positive over a negative is a negative. Who cares? Negative. Negative less than or equal to 0. True. Got that one. Plugging in. Ready? Plugging in 6. Negative 6 plus 8. Positive. Over 6 minus 1.
Negative.
It's false.
6 minus 5 is
False.
positive over a positive is not less than
He says a passive.
false.
Sorry.
10. 10, negative 10 plus 8. Negative over 10 minus 5. Positive. Negative over a positive is a negative less than or equal to 0.
True.
Woo! Don't do it at home because you never know it might go wrong. But we were all working together, double checking each other.
Wait,
What does that mean? Our answer. Because you have no one double checking you. Better to show work and be safe than to not show work and then get. Come back. What is then my solution set or my solutions? Where's the 0 go? Where's the 10 go? What's crossed out? Can I have 8? Can I have the 0?
Yeah.
Yeah, remember? Less than or equal to. So he's good. Can I have the 5? Can I have the, Sean, help us, the undefined point? No.
How come? Sorry.
He makes them undefined.
It's a denominator.
It's a denominator.
How you
Domain
say that?
problem. X can't be found. So it's good to go up, it's good to go down, and it's not good to go in the middle, so we leave him blank. So how do we write that?
I like math.
Parentheses.
And
Negative infinity 2.
Negative 5. 5 parentheses.
It's okay, we'll help each other.
And then bracket,
And
unity
then
bracket.
bracket. Yeah, unity bracket.
I need that bracket.
Okay, Durkin.
Okay.
Woo!
Okay. I might just.
How's it looking? How's it? No, say. How's it looking? You guys are mean. Look at this. He has confidence. Struggle. Venus. Okay, so.
Let's go.
teacher.
So.
I'm serious.
Question.
Yes.
How did the easy way work?
She's done.
I mean, I identified.
We got one. We got one. Who could forget? Now, question. Did it get you a key number? Yeah.
If we're gonna be real.
Right? Okay, so if we wanted to use this shortcut for a key number, look what I'm gonna do.
Oh.
If we're just doing key numbers, we could do that. And we would get down to, hey, a key number would be 2x minus 3x equals 7 minus 15. Negative x equals negative 8, x equals 8. That is a key number. That is a 0. And who else could I remember looking right here?
Oh, the 5.
Oh, and then set it not
Um,
equal to. I thought you could only do that if the other side was 0.
So we could do,
I thought you could only do that if like the other side was 0.
well, but we can see the undefined because he's the denominator even after moving the 3 and getting a common he's going to be the denominator. He decides the denominator. So I could technically do my cool little trick to get the key number 8 faster. And remember, domain problem, I have to include this one as well. And then I could go ahead and go to my sign chart. But do you guys see how it wasn't enough to just solve him? This doesn't work for solving. That doesn't work for solving. It doesn't get you the whole answer every single time. But I can do this trick for the 0, look at the denominator for the undefined, and then I would make my sign chart. And as I made my sign chart, all that would be different is I wouldn't have, I could know the 0 is good. I could know the undefined is not. I would still have to set up a sign chart. But do you guys see where I would plug him in instead? I would still do 0, 6, 10. But where would I have to plug him in? Do I have the nice little one with a 0? No. But where could I still plug 0? Don't do it at home. Into. Here. And 0 minus 7 is negative 7. 0 minus 5 is negative 5. 7 fifths, is that less than or equal to 3? 1 2 fifths. Yes. I would get my right answers.
Okay.
I would just go back to him instead for my testing. I would plug in 6. 12 minus 7 is 5. 6 minus 5 is 1. Is 5 less than or equal to 3? No. Plugging in 10. 20 minus 7 is 13. 10 minus 5 is 5. 13 over 5 is a little bit less than 3, which is true. Would you get your answers? Yes.
We should only like plug in the 6, the middle one, because you know that if that one's true, the other ones are not. If the other ones are true, that one's not.
But usually. So if you're on a test and
Unless
you're
you
running
have
out
a
of
hole.
time, then maybe.
Unless you have a hole in the graph, like between the 6 and the 10.
Or unless you have something like, where's our stuff at? We have a 5, and we have an 8. What if you had something like, when you move it all for 0? Look, they're all above.
Yo,
You know what I mean? But it's not this one. It's not this one. But you're right. Usually it goes below, but not always. Whoop, we can't see finished. Ah, I moved him. Where'd he go? Here he is. What will you do for a Klondike bar? Just kidding. So, lo siento. What did they say? Use a calculator to graph and approximate the values of x that satisfy the inequality. Huh? There's not an inequality. Keep looking. Y less than or equal to 0. How do we use a graph to think of where the y's? Wait, go back to chapter 1. Where are y's less than or equal to 0? Quadrants 3 and 4, because the y's are the heights. Less than or equal to 0 is down. So if I did graph him, question, where is he below? Below slash on. Why do I say slash on? Because it says or equal to. Sure looks like that part. And how would we describe that part? Yeah, right? As long as we can visualize. It would be negative infinity up to visualizing. Looks like -1, right? We could find a 0 and make it perfect. Wait. Parenthesis or bracket?
Oh.
Woo! Careful.
It's dangerous.
Wow. This part. Be careful.
So many details.
Oh no, where's over there? 3? Uh-oh, let's get my poor little X. No, there we go.
Oh, I need.
Wouldn't it be negative?
The negative infinity
On the last one,
On the
like
last
3
one.
shouldn't be negative. No.
Wait, because we're
We're
not
talking
talking
about
about
the
the
X.
Y's. We're talking about the X's. Okay, keep going.
No, I think keep going.
How does this say find the domain, and why on earth is that in the inequalities section?
Because domains are about the X.
You always have to remember how to do domain.
True, and what's the domain problem for? Square root.
Oh, must be greater than.
Cannot be negative, meaning x squared minus 4 has to be, it's an inequality. Look, there he is. It's hidden. So, key numbers.
2 and negative.
That's complementary. All right, so, not complementary. Keeping going. What do you do now? You just randomly plug in numbers and hope you can guess it right. Well, sure. But we can also do our cool little nifty trick and say, hey, sweet, is it allowed to be 0? The answer is yes. So closed. The answer is yes. So closed. We just have to figure out what parts work. So to do that, we go ahead and say center. We have our x. We have our, I wrote f of x, I apologize. I'm trying to write inequality just to say we're plugging into the whole thing. This whole thing, right? What do you guys think? -303? Does that sound good? For test representative values? Plugging in -3. Don't do this at home. -3 plus 2. They're battling each other to take away. So -3 plus 2 would be -1. Negative. Ooh. Plugging in -3, I would get a negative times, what's -3 minus 2? A negative. A negative times a negative is a, right? Take your time, plug it in if you need to. If I plug in 0, what's 0 plus 2? A positive. See what I'm doing here? 0 minus 2. A negative. What's a positive times a negative? Oh, false. And then plugging in 3. 3 plus 2 is a positive. 3 minus 2 is a positive. And a positive times a positive is a positive, which is? True. True. So who works? All of those guys. All of those guys. And who doesn't work? None in the middle. So how do I state my domain? Hence, my intervals where it works.
-3 or -2.
Careful. Start on the left. And then negative infinity. All the way up to. Careful, careful. Look at your number line. Don't look here. That's my mistake.
With the
-2
bracket.
with the brackets. Or.
And then 2.
Look at you guys rocking the nasty domain of a quadratic and a square root.
The world.
Cheers. I don't know.
Cheers.
It's unfair.
All right, let's see how much harder it gets because we have like 2 minutes.
Stay away.
Oh, then we're done. Okay. Hold on. Wait. Shh. We still have this. Applications in business.
Oh, business. Let's go, majors.
How do you get profit? You take what you get, revenue. You subtract what you spent, cost, and whatever's left. Anyway, just something to keep in mind when you get done. And what are clue words for inequalities?
Whoa,
We have to stop.
the time stopped.
At most. At least.
No word.
More than. Less than. Stop. Some of you aren't good at this. What inequalities would you put for at most? At most, there is a highest, so it's below.
Oh, God.
At least, there is a lowest, so it's above. More
Less
than.
than and greater.
Let's
Greater than less than.
Alright.
Way to step out.
Yeah,
We got this. Confidence.
Woo.
Here goes. We're
We're
going
gonna
on done by tomorrow.
We're gonna go check the other classes. They're all like
2.7.
close.
But wait.
There's more.
Over the weekend.
Which means 9.
Test, reps.
So if you have more time tonight than Saturday before school events, you might want to.
No, dude.
Bye, guys.
That was so weird, guys.
Hello?
What's that?
Celeste. Go to the main
You want a
office.
nectarine? Yes.
Bye. Wow. At least 4:30.
I have lots of things.
We can deal with sticky notes. We can do that. Yeah.
Should I finish up 2-6 left?
Alright, so we'll try to finish up 2.6 and maybe talk about 2.7.
Okay, Alfred. Okay.
What? It's in my fire.
I actually ate today, Miss D. I brought lots
Yay! Go team!
of food. All foods. I got to number 8 last night.
The 5-5?
Yeah.
Go team.
Hey, one problem.
want us to do anything for him? I'm gonna talk to him.
One problem.
Let me know.
Whoa.
Mom, I need help on 2 of the ones that from yesterday, the ones earlier, and the ones yesterday. Like 27.
alright?
If there's a tour coming, let me know.
You doing alright?
I'm gonna go with no.
But can I really just sit here? I'll take notes of that. Thank you.
Do you actually have your notebook?
No, but I saw how good my notes. But probably just.
Look at the picture today and see. Yeah, because I put this on and a sweater. You're still recording.
I got you. Oh, and you're recording audio? It's amazing.